Okay, this is the last part that we stopped, yeah, last time. Skew Hermitian matrix. And if you remember, okay, we have not gone to the Hermitian. Okay, let me see. Okay, the last time Hermitian, I mentioned about the diagonal, right? The diagonal has to be real and the opposite has to be conjugate. Okay, that is Hermitian matrix. Then there is a unitary matrix in which I wrote here, right? You multiply A bar transpose has to be identity. Okay, that's straightforward. And this skew Hermitian is such that A bar transpose is negative A. Okay, it's negative A. And if you look at the this matrix, the diagonal has to be all complex. Okay, the diagonal has to be complex, and the opposite mirror has to be the not the conjugate but the negative of that. Let me see. Okay, so you have A is Aij, right? Okay. A transpose is Aji, right? A bar is Aij bar. That's the conjugate. Okay. Now, for this skew Hermitian matrix, you want this to be this. So, for, let's say for I is J, right? You have two cases, right? When I is J, okay, what is A bar transpose? Okay, in terms of the entry, so this is Aji. The bar, right? And then the transpose. Okay. And when I is J, you want Aii bar, because I is J, so Ji is Ij, is equal to negative, negative Aii. Okay. So if Aij is x plus Iy, complex, yeah, complex. Normally we use Z is A plus Bi, right? When you learn complex numbers. But since we already use A as the entry of a matrix, I'm not going to use A again. I use X and Iy. And from this, okay, because I is, this I is not this I. It's going to be confusing, right? This I is the row, right? Because we use Ij for the row and column. This I is this I. I is the square root. So you know what I mean, right? For this one, sorry about the confusion. I should change, but we used to use Ij. Okay, so Aij bar is x minus I bar. That's the conjugate, right? That's the conjugate. Okay, so when I is equal to J, you want x minus Iy equal the conjugate, yeah? Because this is the same, so don't worry about the Ii or Ij. This is negative, so I will just use this for this case, right? The negative of this is negative x, the negative minus Iy. Yeah, you want to see what happened to the skew Hermitian matrix in general. So you cancel, right? So you get x equals negative x, bring the other side to x is 0, x is 0. Okay, so this means the AII is just IY. So, as a conclusion, where I moved. Okay. Therefore, for this first case, I put here. Oops, AII is IY. Yeah, that means at the diagonal, you can see all just complex number, no reals. If there is a real, then you cannot have this equal to this. Okay, you will see this when you do the exercise. The second one is, what happened is I is not equal to J. Okay. The second one is when I is not equal to J. Okay. You will write this, right? This. X minus IY we want it just the negative, right? The bar transpose equals the negative. The same method as we did before. Remember, we did this for the antisymmetry, right? Antisymmetry matrix. So this changed to AIJ. So the AIJ bar is X minus IY. Got the answer? And so if you solve this, you will get A equal, okay. This one has to be YI or IY, right? Along the diagonal, maybe I use YI1, YN, right? And this, if you have, I don't want to use XY, but let me see, just A plus BI. Then the other way is negative A plus BI. Okay, this is what you will get. So that's, I think that's the end of the. Do we have any more matrix? That's it, right? Yeah. So as an example of a matrix, as given here, A is I1 plus 2I, -1 plus 2I, right? Negative. And you can put anything at the diagonal as long as you have the I. Okay. Then you can try and check whether A bar transpose is -A. That is how you prove that it is skew Hermitian. Okay, now we go to matrix operation. I should have finished this last week, but I think it's okay because this is just the basic things that you have learned about the operation of the matrix. So the first one would be, okay, this is matrix operations or operation of matrices. So the first one is addition. You know how to add matrix. You can only add matrix if they have the same dimension, right? So let Aij m by n and Bij m by n, then A plus B is just adding this Aij plus Bij, and what you do is adding the corresponding entry. Okay, you add the corresponding entry. So they have to have the same dimension. Okay. Okay, you can go through the example. It's straightforward because you have done this in your quiz. I can see that all of you remember how to add matrices, right? Just give you one example. If you have 1, 2, easy, right? -3, -4. Because they have the same dimension, you can add, just add them together. This, the dimension does not change. So you get -2 and -2, right? So just add up the corresponding entry. All right. What you have to know about the properties of matrix addition. This is still high school, right? So what you have to know about this property of this addition is that, is this okay? Jempol. Okay. I will erase. Okay. How do you show A plus B is B plus A? Okay, because this is general. Okay, keep in mind that if you have to show something in general, you cannot use example. Okay, you have to show in general. So then you have to write the proof. Okay, using the definition. Okay, this is what you will do until probably you do your PhD. If you get a statement to prove, is write out what is given and show what do you need to show in general. Okay, so you take A plus B, you have to write this, let A equals this, copy paste. Let A equals this, then A plus B is this, right? Aij plus Bij. A plus B is, you write this, you write this, you write this, I just copy. Okay. But this one, you know you want to show that it's equal to B plus A. this is just number, right? This is just any number. It can be complex, it can be real. So number, you can do like this, right? Because they are numbers now. And this, by definition of matrices, go back here. You can do like this, and then you can go like this. So this is Bij plus Aij. This is the definition of addition. Okay, you can separate, and this is actually B plus E. It looks really easy and straightforward, but this is the steps. You have to write out the steps. Okay, you do the second one. Is it in the notes? Okay, it's not. You do the second one. Okay, the second one says associative law. Yeah, this is called the commutative. Okay, this is commutative. This is okay, yeah? Okay. Commutative, the second one is associative. After this, if you ask whether matrices are commutative or not, then you know already it's commutative. And the proof is in this class. And after this, if you ask whether matrices are associative or not, then again from this class, we have proof it is associative. You will see this in discrete mathematics. You will see this in modern algebra. Okay. So it's your task to write out the proof. Okay, you will start from here. You will write A is Aij, B is Bij, C is Cij, and then you will add, because addition is 2 at a time. You don't have addition to 3. Yeah, addition is defined as 2, but numbers, you remember numbers is also associative. 1 plus 2 plus 3 is 1 plus 2 plus 3. Or it's just 1 plus 2, 1, 3, right? We normally will take it all the lump sum. All right, so this is your task, yeah? Start from here and then do this. And then when it's already number in the matrices, you change the bracket, the parentheses, and then separate. Okay. Third one. A plus O is A, and this is also O plus A. Okay, and this is called the identity matrix under addition. Try and prove this. I will give you 2 minutes. Oh, gallery. Okay. Speaker gallery. Okay. So you will take O is like this, right? That is O. So A plus O is Aij plus 0, right? Which is Aij plus 0, which is Aij, which is A. Okay. Then you can do this side, right? Or you can just write that, switch this. There are many ways. You can do from this side equal to this, or it's just from here, right? You can put, which is 0 plus Aij. Because Aij is 0 plus Aij, or Aij plus 0 is 0 plus Aij, right? So this is O plus A. Yep. Okay. So this is how you show from matrices using numbers. Okay. Next is properties of matrix. Next is matrix multiplication. Oh, I'm really sorry about 1.3.3. Okay, 1.3.3 is supposed to be the operation of matrix multiplication by a scalar. Oh, the one that ordered the books, they are doing the cover, they are printing it. So hopefully by this week, yeah, I will let you know, I will update you. Okay, so this is matrix multiplication by a scalar. Number 2. Multiplication by scalar. Scalar is just a number or a real number, that's scalar. Okay, so let A be Aij and K is a scalar. A scalar is just a real number. Then K multiply a matrix. Oops. Is K times that matrix is a matrix with every entry multiplied by K. Okay, it's a matrix by every entry is multiplied by K. So you can see the general formula if you write in terms of the whole matrix as this entry, A11, 12 until N21, 22 until N M1, M2 until Mn. It has to be 3, yeah? So the answer is equal to, I make it smaller, K, A11, K, A12, K, A1n, K, A21, K, A22, K, A2n, K, AM1, K, AM2, K, AMN. Okay. So this is how you define multiplication by scalar. And for example, A is 1, -3, 2, -1, 0, 10. Yeah. So -2A is equal to, because you can do it just straight in your head, right? You can write out, but you have to multiply -2 to each one, right? So this is -2, -4, 0, 6, 2, -20. Okay, you have learned this before, right? And I gave you some other examples in the notes. Okay, let's look at the property. right? The properties. Okay. Pada. Properties. The first one is K of, you multiply the sum by K is the same thing as multiply first, you then add. Yeah, whether you add first, then multiply, or you multiply first, then add. And how do you prove this? So you have to write the proof like this. Proof, let Aij, B, Bij, and there's m by n, right? Because you want to add. And K is a scalar. Then, so this is what I mentioned earlier. You have to write out what is given, and then you have to prove what do you have to prove. Take the left-hand side, then replace with your let, right? Is equal to K Aij plus Bij. Okay, remember your definition is only K times one matrix. If there is this one matrix, you can multiply K, bring it inside. But you need one matrix. This is two matrices, right? Two matrices. So you have to add first. And this is just replacing, right? Just replace. But you have a definition of addition, right? So this is multiplying. So now it's inside. Right? Now this is a matrix. Okay. This is just the regular parentheses. That is why they use this to differentiate a matrix by multiplying with the parentheses. That's why the difference, right? I should actually use this as a matrix so you don't get confused with this. This is multiplying. Okay, now it is a matrix. You don't mind I erase, yeah, for matrices. So just show this is a matrix. Okay, so you don't get confused. Okay, now it's K times a matrix, right? Then you can put this inside as a matrix. But in the matrix, the entry is in terms of a sum. That's why I put this parenthesis. Then you can put K, Aij, because this is just numbers. This is just now numbers. So you can just multiply. And then there is a sum inside a matrix. You can separate. And then from here to here to here, right? To here. So this is K Aij plus K Bij. And this is what you want to get. Okay, remember we want to show here. We start from here, you have to end from here. So this is Ka plus Kb. Let me see if, yes, you can see this. Okay. Good. All right, and there is another one that you have to prove. Okay, I will leave it to you to prove it. And number 4 and 5, let me just write out what I want you to prove. Okay, so number 2, K1 plus K2A. Now this is numbers, yeah? Scalars, real numbers. Multiplied by A is K1A plus K2A. Again, when you want to prove this, this is a matrix. And use this, bring this inside. When it becomes a number, then you can separate and write like this. The third one, when you multiply two numbers of scalar from outside, you can do either way. Okay, actually you can just multiply first the scalar, but this is just a property that you should know. Silap lah ni. Yeah, and when you multiply two scalars outside, when A, you can actually multiply this first. So it's like not really called associativity under multiplication because it's numbers. But why do we want to multiply first? Sometimes because this will give you something important rather than multiplying this first. Okay, that's the reason. Okay, 1 times A is very easy, right? If this is 1, this is 1. 1 times A is just A. Okay, and the last one, 0 times A, what happened? 0 times A. 0 times A is 0 times D, which is all 0. So this becomes O. Okay. Ngap dah. Kena exercise. You know. And you have to know your own 0 and your own O. Okay. Imagine if you write your 0 is like O, your O is like 0. I'm grading your quiz or your test. I had to give marks to make sure. Now, matrix subtraction. Okay, the next one is matrix subtraction is just add the negative. I'm not going to go more into this, but this is what is defined. That's why when you do this, you actually is doing this plus and then -1 and then Bij, which is actually this. Then that's why you can just do this. Okay, we take it for granted that A minus B is just minus. Actually, it's not defined that way. We only define addition and multiplication by scalar. And then they came out with just putting in a minus. Don't take it for granted because that is all only defined for numbers, not for matrices. But now we have seen all this way and we take it always for granted that if A minus B, you just minus inside. But there is a story behind. This is the story using the previous two operation. Okay. Okay. Now there is an exercise in the notes that you have to do. Fill in the blank. Okay. You are given matrices to find. I will leave it to you later. You have to fill it out. Okay. Now, my question is matrix subtraction commutative? Is A minus B equal to B minus A? Yes or no? Thumbs up or thumbs down? Yes or no? Is A minus B equal B minus A? can type or you can do. Ada yang jawab thumbs up. Eugene, you have to do thumbs down. Nah, macam tu. It's not. Yeah, it's not. So this is not equal. Not equal. Definitely, right? Okay. But A minus B is the negative of B minus A, yeah? Right? We think about it as numbers, but they are not necessarily numbers. But when we do the operation inside the matrices, it becomes just like numbers. What about associativity? Is it associative? Yes or no? A minus B minus C, is it equal to A minus B minus C? Eugene, you give a thumbs up. Yes or no? No, no, no. No, right? Because this is actually equal to A minus B plus C, right? A minus B. This actually has some calculation, again, using the proving, but we just, again, take it for granted that we can just do like numbers, but it works like numbers. It's not, yeah? Okay. Now there are more properties of combination of matrix operation that you should go through under multiplication by scalar add up to addition. Okay, you go through the properties given. Okay, now I want to mention about multiplication of matrices. You have done this in the quiz. I think now you remember, right? I'm sure you have read through today's notes. So the last operation is matrix multiplication. These are basics, but if you make a silly mistake, right, very careless mistake, then you will use this actually until the very last chapter. Okay, and be careful when you multiply. You have to check again. Okay, check again your answer. Sometimes the easiest part is the one that you miss, right? You don't get the right answer. Okay, now let A be Aij M by P. Oh, M by N. Yes, I want to do this. M by N, B, N by P. Okay, so like I mentioned in the very first class, the column of this has to be the same with the row of this in order for you to be able to multiply. Okay, then the product, AB, call it Cij, M by P. Okay, so when you multiply together, this is the product. Okay, multiply is a verb, product is the noun. Cikgu bahasa Inggeris lah, eh? Because in your final year, you will have to present, right, your undergraduate project report. So make sure that what you said it. Okay. Cij is equal to the sum of A ik b kj, you see, the k has to be equal and the resulting is the ij. And this k runs from 1 to n. Okay, this is actually the formula when you multiply. So you can write out, right? When k is 1, so what does it mean? Okay, let me try and multiply. Write out first, right? Write out first. Okay, aij. A11, A12 until A1n. A21, A22 until A2n. AM1, AM2 until AMN. And then B11, B21 until BN1. B12, B22 until B21. B1P, B2P until BNP. So if k is 1, okay, if you want to find I is 1, and j is 1, you will get, I write here, yeah? C11, yeah? Okay. C11 is 1, I is 1, j is 1. You will get C11. When this is 1, you will get k runs from 1 to n. So the first one will be A11, B11. Okay. And then k is 2 plus, this is plus, right? So A11, B11 plus A12, B21 plus until A1N, BN1, right? The I and the J stays, the K runs from 1 to N, and you add 1, 2 until N. This is actually this one times this one, right? Yeah. A11 times B11 plus A12 times B21 until A1N times BN1. That is to get the first one. The first one. So C11 is this. And then you have to go through how many times? How many times? All m times p times, right? To multiply out. So this is the formula for I equals 1 to m and j, because the resulting here is m by p, yeah? M by p. So I from 1 to m, j from 1 to p. You have to do this m times p times, right? So the second row here, C21, will be second row times this and so forth. You have seen this and you have done this. I can see that you still remember this from quiz 0. Okay. Right. Okay. Yeah. Okay. Now the property of matrix multiplication. My first question, is it commutative? Is AB equals BA? Right? No. AB is not BA. Why? Why? Nabil. Hari tu saya panggil Nabil tak ada. Nabil kena unmute. Soalannya ialah why AB is not BA? Why? Agak-agak kenapa, Nabil? Alah, saya tak nak padam, dia dah terpadam. Yeah, why? Just now I wrote A is Aij M by P, right? B is Bij M by N. M by N, N by B. Then we have AB is C, Cij M by P. So why AB is not BA? Ada pula talian hayat di situ. Okay, that's what Eugene said. The terms in the summation. What does it mean, terms in the summation? Just now, the one that I erased, right? When you add up, that's not that clear to me, the answer. Nabil, let me help you a little bit. For this one, can you multiply B times A?
B times A.
If you have A, M by N, B is N by P, right? You will get C, M by
P.
If you have B, N by P, A, M by N, can you multiply?
No, cannot.
Cannot multiply. So the first reason that you cannot do AB is BA is probably the dimension. You cannot even multiply. Yeah, you cannot even multiply. Okay. Now let me change the question a little bit. Suppose they are all N by N. Okay, N by N. Can you multiply? Nabil?
Yes.
Yes.
That's
right?
what I say.
And the answer is N by N. So let me ask again. Are they equal?
Depend on situation.
Arif, Vineta, semua dah jawab. Go back to what Eugene said, right? The terms inside might not be the same. When you multiply and then you do the other way around, the rows and the columns, you can try. Saja bagi apa? Trick question. You can do easily. 1, 2, 3, 4, maybe multiply by 1, negative 1, 0, 1. Try multiply. 1, negative 1, 0, 1 times 1, 2, 3, 4. Okay. Tadi row column. 1, negative 1 plus 2, 1, 3, negative 3. Okay, this one, negative 2, negative 2, 3, 4. Right? Jangan angguk je ya, kena kira ya. Mana tahu saya tersilap. See, they are not the same, right? Okay, so you probably can multiply, but the entries are different. So in general, multiplication of matrices is not commutative. Yeah, multiplication of matrices is not commutative. AB is not BA. But, there is a but. There are matrices that makes the multiplication commutative. Which kind? What kind? Which matrices? Okay, before that, it is associative, and there are, again, all the list of properties that you have to go through. You don't need to know how to prove. For multiplication, it's different, right? You want to multiply all in general. It's not the same like directly addition or multiplication by scalar. How do you show it's associative? Just we take it that it is associative, right? For multiplication. But to answer my question just now, A times I is I times A. Okay, for this one, yes. We say that I is the identity matrix and it commutes with all other matrices. That's why I is called the identity matrix under multiplication. Okay, just now I mentioned about the zero matrix is the identity matrix under addition. Why is it called identity? You multiply with it or you add with that matrix, it won't change the original matrix. And that is what you call it identity. Yeah, so for this one is, you can try and multiply, right? It has one in the diagonals, you multiply, you will get it back. Or you put in the original definition of multiplication, then you see why you get the Aij back. When you multiply, Bij as one in the diagonal and the others are zero. Okay. Under matrix multiplication, we define also the square or the power of a matrix. Yeah, the power of a matrix is how many times you multiply that matrix by itself. Okay. And so if you want to find A to the K, you multiply this, put like this, K times. Then you will get. Okay. And I mentioned about nilpotent matrix, right? A matrix is nilpotent if the power to the K of A is equal to 0, right? So you multiply A, K times. Okay. And before we take a break and go to elementary row operation, okay? One of you dah semangat dah during weekend ke apa? He asked me about the elementary row operation. Today I will reply you. Saya kata sabar, rehat nanti, rehat ya. Okay. Okay, last one is the trace of a matrix. If you have heard this before, okay, trace of a matrix. So let A to be Aij, and it has to be square before we can find the trace of a matrix. And the trace of A is defined to be the summation of the diagonal. You just sum up, take the sum of the diagonal entries. That is the trace of a matrix. So for example, if I give A equal 1, 2, 3, 4, 5, 6, 7, 8, 9, then trace of A is 1 plus 5 plus 9, which is 15. Okay, you should be asking yourself, why do we need to find the trace of a matrix? That's your homework. Google why. And why? Why is it important, right? So this is the trace of a matrix. Okay, let me ask you, what is the trace of the identity matrix I2? What's the answer? You can type in the chat. Easy question. Okay. So I2 is the identity matrix. The answer is answer 2. Trace of I3, 3, that trace of IN, and see, there is a pattern, yeah, that you have to know in general. What is the trace of the zero matrix? Ush, lambat nak menjawab. Okay. Okay, dah betul, kita boleh rehat. Let me stop. We go for 5 minutes break. Let me. Any question about anything so far before I move on to elementary row operation? Or is it okay? Okay. Right. Good. Okay. Okay, I want to tell a secret. Last semester, I give bonus point in the final grade to students who really interact in class, video on. Okay, if your internet is slow, come back to UTM. Macam promosi. All right, so we finished that part, and this is the most important part of the semester. As I mentioned in the last class, if you cannot understand or you cannot master elementary row operation, you will not pass this class. Ugut, that's the truth. So you really have to understand. I did not say it's hard, kan, right? But you have to really understand. If you don't understand anything that you need to ask during class. Please don't, if you send me a personal message, your friend probably is thinking about the same thing, right? If you really, kita ada wakil kelas hari itu kan, then put in the whole group, I don't mind. If you ask anything regarding the class, as I mentioned, no question is a stupid question. Yeah, the others might have the same question. So if 60 of you send me in a private message, I ask during class, no question, and then you send me messages. Tak sempat saya nak balas dah. Okay. Anyhow, elementary row operations. Operations with the S, because we have more than one. Okay. The first one is interchanging two rows. You need to use my symbols, okay, and the one that we use in this class, in my notes. If you refer to some other books, they probably use a little bit different. Or if you have learned this before, maybe you have seen this before, you have taken related classes, or you have to use this one to be consistent. Yeah, I will not tolerate with a different row operation. Okay, and the symbol is RI interchange with RJ. We interchange the row. Okay. For example, maybe you have this matrix. What is that? Then you want to change R1 with R2. So you will write that little, the operation there, the elementary row operation, and then you change 1, 2, 3, 4, 5, 6. Okay. This is interchanging the first row to the second row, right? You only change 2 rows at one time, at one operation. Okay. Then the second one is multiplying a row by a non-zero scalar or number k. Okay, and you write k r I. Yeah, k cannot be 0. Scalar means k can be any real number. It can be a fraction. It can be negative. Okay. The third one, adding a multiple of row I to another row j. A multiple with the same k in R, k is not 0. So k Ri plus Rj. Okay, k Ri plus Rj. So an example of multiplying this is easy, right? Just maybe we want 1/2 R2. You can multiply at the same time, row 1 and row 2, because they're separate, right? But I just do this one. So you will have 2, 5/2 as an example, right? What you write. Okay, I will use this same matrix. Okay. To do this operation, later I will tell you why I do this. -4 row 1 plus row 2. Multiplying one row I to another, adding a multiple of row I to another row j. And k can be negative, as I said, right? The one that you change is the one that you write on the right. That you write on the right. English again. So this is the one that you change. The change row is the one that you write on the right. Okay, and what will you get? Ya, Nabil, hari ini kita panggil Nabil. Okay, what do you get for the second row? Because we changed the second row. You multiply this by -4 and then you add.
0.
0, -4, and add.
-3.
Okay, -4 and add.
-6.
-6. Yeah, so this is Shariza. You raise your hand, you have a question?
Doktor, macam mana nak tahu yang kita nak pakai dekat rumah mana satu?
Itulah saya kata, I will tell you why I do this. This is just macam nak tunjuk je how do you do this operation.
Okay.
Okay, there is not really a reason specifically, but sebenarnya ada, but later. Eugene, what's your question?
Prof, can we do like row I plus k row j?
No,
Cannot.
No. You
Need.
cannot do rho I plus k rho j. Strictly, you have to follow this. And strictly, this has to be a plus. Yeah? And strictly cannot multiply both by k1, k2. Although you know it's a shortcut, you know it's shorter, cannot. There is a reason. Later on, there is a reason in the probably next chapters. Why? But this is strictly like this. Okay? Yeah, Rada.
Prof nak tanya, so that means depan RJ tu kena always 1 je lah eh?
Exactly.
Oh, okay. Thank you, Prof.
It has to be this. You can change. It has to be this multiplied by this. This is always a plus and this is always a 1. Okay. Dah okay? Boleh turun tangan. Ada soalan lain, Rada? Tak ada. Alright? Clear, ya? Okay, clear? It's okay, don't worry. Takut dah. We will do lots of examples and exercises, yeah? Okay, so this is the 3 elementary row operation. Alright. Okay, now okay. I will do examples later, but when we do row operation from one matrix to another, we call those matrices are equivalent. They are not equal, but they are equivalent. Yeah, we have changed from one to another, reducing. It's called reducing the matrix using elementary row operation. And why? What for, right? So that is come this row echelon matrix. Okay, row echelon matrix, or in short, I call it REM. Okay, a row echelon matrix has some properties, right? The first property is that consists at least one non-zero row. Meaning it cannot be a zero matrix. Okay, it cannot be a zero matrix. We want a row echelon matrix which is non-zero. Number 2, the leftmost non-zero entries, the left, you know your right and left, right? I know some people, they're not sure which one is the right, and you drive and then, okay, turn right, they will turn left. Right is, makan kan, tak ada kanan. Okay, the leftmost non-zero entries in every row is 1. Okay, and then we call this entry the leading one. We call this entry the leading one. Okay, number 3. The leading one in the lower row, the leading one, you know, one. The leading one in the lower row occurs further to the right. Then the leading one in the upper. I will give you an example, don't worry. And the last one, if there are 0 rows or rows of zeros, right? All zeros, they are grouped and put at the bottom. Okay. Bottom of the matrix. Okay, guys, you don't need to copy this. Everything is in the notes. Okay. From now on, I want you to look at my screen. Okay, look at my screen. Don't worry, it's there. I just want to explain. Okay. You won't miss anything. I just want you to understand when I explain this. I give this as the first example. 1, 2, 4, and then I have this. Okay. Okay. Now we look and we check why this is a row echelon matrix. Rule number 1 is not a zero matrix, right? Because you see some entries. Okay, you see some entries. The second one, this is okay. The leftmost non-zero entries in each row, so you have to go to each row and look from the left and see what is the number. The number has to be number 1. Okay, so you go the first row from the left. Yes, I will circle that. Right, that is the first non-zero entry from the left. Go to the second row. Where is the first non-zero entry? Yes, that is the leading one. Okay, it does not say that every column has to have a leading one, right? It says just only the first non-zero has to be 1. And then there's nothing here, it's okay. That covers number 2, right? Number 3, the leading one in the lower row, this is lower than that, right? The leading one occurs to the right, right? So this is like you go down, you go to the right, you go down, you go to the right, you go down, you go to the right. Turun tangga kan? It cannot be underneath. So this is the leading one. When you go to the next row, you go to the right. Okay, right? So it covers this one. And if there are 0 rows, they are grouped and put in the bottom. There is only 1 0 row and it is at the bottom. Right? Okay. Okay, clear? All right, okay. Next, I will give another example. Also in the notes, yeah? One, 2, -3, 0, 1. 0, 1, 0, 0, 2, 0, 0, 0, 1, -1, 0, 0, 0, 0, 1. Okay. Okay, so the first thing that I would do is to circle the leading one, right? So you go to every row, don't circle all the number 1s, only the leading one. Habis semua kena circle. Go to each row and circle the first number. Okay, so first row, second row, third row, fourth row, right? So, okay, they're all 1. and they're all to the right, done. Right? So this is a row echelon matrix. Okay, senang je kan? Di Proniza ni menakutkan orang je. Gitu. Alright. I will introduce another matrix. Okay. And then how do we get these matrices? The next matrix is called row reduced. Row reduced echelon matrix, which we write RREM, row reduced echelon matrix. There is another additional, an additional property after all this that I will add here. Each column that contains the leading one has zeros, column, yeah, everywhere else. Each column that contains a leading one has zero everywhere else. All right. Okay, meaning you see this? You see this? Is this row reduced? Okay. Okay, so you look at the column. You look at the column that contains a leading one. All right. So this is the column that contains the leading one. It is okay that this column does not have a leading one. It is okay. Just look at the column that has the leading one. Yeah. So this column has a leading one and it's zero everywhere else. So it's checked, right, for that one. The second column, that's a zero, but this is not zero, right? It's not zero everywhere else. So in this case, this is not row reduced, okay? Not row reduced. And you don't look at this because there is no leading one. And here, I just want to show where we can stop because this is already not, but there is another reason that this is the leading one, but the rest, they are not all zeros. Yeah. Okay, so there are some other examples in the notes, but I will write out some other examples and I will ask you whether this is yes or this is not, yeah? Okay, so I will erase this. Then we do the operation, right? So, examples. Okay, example number 1. Example number 2. Example number 3. Example number 4. Okay. I give you 2 minutes. Okay, 2 minutes is up. Sekejapnya dah 2 minit. Okay. I want a volunteer. I'm not going to call you names because it's not fair, because I can only see the one that has video on, right? Maybe you want to try. It's okay if it's wrong, right? Okay, the first one, who want to volunteer? Raise your hand. Yang belum pernah bercakap. Tak ingat rule kelas saya ni. Eugene dah bercakap hari ni. Orang lain. Nabil dah bercakap. Amirul dah bercakap hari tu. Kalau tak ada saya panggil nama. Okay. I will call the one without video ya. Okay. Patricia dah pernah bercakap loh. Semua ngaku dah pernah bercakap. Can you raise your hand, Patricia, so you will be moved to the okay. Dia P saja. Okay, can you unmute? Yes. Okay. Yes or no?
Yes.
Yes. Okay. Patricia said yes. Okay. Okay, dah. Lower your hand. Putri Atira. Raise your hand. Putri Atira, are you here? Unmute. Okay tak? Boleh unmute tak? Kalau tak boleh, boleh chat. Yes or no? Yes or no? You can type. No, ya? No. Okay. Aimi Sophia. Raise your hand. Okay. Can you unmute?
Yes.
Oh, meriah. Your answer is yes or no?
For number 3.
Number 3 dah dia.
Oh, sorry.
Okay, number 1. It's the same question. Oh, tadi kau buat nombor 2 ke? Yang tadi. Still number 1. Still number 1.
Okay. No.
The answer is no. Why? So you do the leading one here, right? Okay. Then you go to the second row. The leading one is here. And then you go to the third row. The leading one is here. So what is wrong? What is wrong? The leading one here is not on the left, or the leading one here is not to the right. Kan? Turun tangga patut ke sana kan? Right? The leading one here is not to the right of the leading one here. So the answer is no. Tak tersusun. So that is the reason, because you have to write out the reason. The leading one in the third row is to the left of the leading one in the second row. It's not to the right. That is the reason. Okay? Number 2, yes or no? Type je lah. Lambat nak lah you all ni. Kat tangan lah nak mute lah. Ni lah. Okay? Jawab cepat, jawab cepat. Okay. Yang jawab no tu bagi reason. Yes tak payah bagi reason. No bagi reason. Cepat yang cakap no tu. Apa reason dia? The answer is no. Because the one with all 0 entries, it is not at the bottom. Itu je punya cara jawapan. Bukanlah first row all 0 entries. No, you have to write the row with all 0 entries is not at the bottom. Jawab kepada the rules. Yeah, okay. So the problem here, okay, go here, and then here, and then here. Okay, fine. Okay, it's to the right. But the row with 0 entries, it is not at the bottom. Okay, so the answer is no. Number 3. Kenapa? Tak nak lah, saya tukar soalan sama. Sorry, tukar soalan. Masih jawapan yang sama. Okay, yes or no? Number 3. Number 3. No, 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 no. Jawapan, because it's the same reason with number 1, right? So you put it. You put the 1 here, 1 here, 1 here. So there are 2 reasons, right? There are 2 reasons. The leading one in the second row is not to the right of the leading one in the first row. And also, that is one of the reasons, then you can just use that. Okay, last one. Yes or no? Yes, no, yes, no. Number, last one. Okay, why? Why? Ada tak yang bulat ni? Because it's number 1. Okay, mana boleh? You have to circle the first one and it has to be 1 before you can circle it. So you go and you see it's number 4, right? The first non-zero entry at each row has to be 1. Okay, has to be 1. So this is not 1, this is 4. So I don't want to circle, I just do this. It is not a row echelon form because the first non-zero entry in the first row is not 1. That is how you should write it out. Okay, accordingly to the property. The rest you don't care because the first one is not. Okay, now I have not given you. So this is no, this is no. How come it's all no? One more example before I move on. Number 5. How do I do this? I want this to be Ah, okay. This is nice. All many zeros. Yes or no? Yes or no? Is it REM? Is it RREM? So I need two answers. Yes, yes. Yes, no. Okay. So the first one is 0. And then 0, 8, 1, 1, and then they're all zeros. Okay, so this is REM and also RREM. Okay. Okay, now I will take one example from the notes. I will reduce to both, but you cannot write anything. You just have to look. Okay, because it's all there. I don't want you to look anywhere else except for my writing. Okay, don't worry. You have it there. So this is why you will need to use elementary row operation. Okay, let me. Oh, here. Okay, let me get quite a long one. I have many others, yeah? Okay. Exercise 4. Okay, I will give you time to copy later, but I want you to give your full 120% to 100% concentration. Okay. The question is, reduce this matrix to row echelon and row reduce. Okay, that is the question, yeah? 1, 2, 3, 2, 5, 3, 1, 0, 8. Okay, before this, let me read the rule. Let me read the rule. First, is in the notes. First, make the leftmost non-zero entry at the first row or first column, not necessarily, but first row. Sometimes you cannot find it in the first column, to be 1. Okay, make the leftmost non-zero entry at the first row, maybe first column, 1. Okay, then how do you do this? You can interchange the row if it's not already 1, but try not to multiply by fraction first, because we want to try not to use fraction in the very beginning. Otherwise, you probably will make silly mistake, careless mistake with fraction. Okay. Next, use this leading one to change the entries below in the column to be 0. And then you do this again. Okay, so let's start. Are you watching? Are you watching? Are you not writing? Okay. All right, so the first step is already 1. Okay, so the first row, first column, already 1. Then the next step is to make everything underneath all 0. To use the third in the elementary row operation. How do you do this? The number here is 1. You want to make this 0. So you use this number, but take the negative. So negative 2 R1 plus R2. That will make it 0, right? Yeah, so you use the number 2, but take the negative. You can do at the same time to make this one 0 also, to reduce the number of matrices that you have to copy. So negative row 1 plus row 3. Okay, so this is already 1. Whatever the number is, take the negative and then add, and you will change row 2 and row 3. So you will not change the row that you use, which is this. Don't change row 1. So it's still 1, 2, 3. Negative 2 row 1 plus row 2. So negative 2 plus 2 is 0. Negative 2 times 2 is negative 4 plus 5 is 1. Negative 6 plus 3. And then this is easy, just the negative and add. So 0, negative 2, 5. I will always check my step at least another once more before I make a mistake here and then it carries. Yeah, so I will check again. Okay, negative 2 and add, negative 2 and add, negative 2 and add, negative and add, negative. You can write it also kat kertas conteng lah, but just can do it in your head also. Okay, next one is I already have this one. So you go to the next row to the first leading. Okay, this, oh, it's already 1. So you are safe. If it is not 1, you have to do row interchanging or multiply by fraction. But multiply by fraction, do it last. And number, this is very important rule. If this is not 1, we have finished the first column and the first row. Do not ever do something with the first row again. Cannot interchange from the first row. All right, and then you kacau lah. Then you will go like, you know, if you drive, you go to a roundabout, you won't get out of the roundabout. You go in and then wing, right? So you have to follow the rule. The next rule is the underneath. Later on, I will mention about row reduce that you have to do both, but at this time, you do under, yeah? So this is number 2. So you will do 2 row 2 plus row 3. Because this is number, take the negative, right? Then you will get copy 1, 2, 3, 0, 1, negative 3, okay? This won't give anything, so 0, 0, multiply by 2 and add will be negative 1. Okay? Do it again, try again. 2 row 2, this one copy, this copy, and 2 row 2, because this is 1 and this is negative 2, so negative or negative is 2, nothing, 0, negative 6 plus 5 is negative 1. Next step, done first row, done second row, go to the third row. So this is done, this one. What do you multiply with or do with the third row to get 1? You can either multiply by 1 over negative 1, but you can do negative row 3, right? That is multiplying by scalar. Okay, so 1, 2, 3, 0, 1, negative 3, 0, 0, 1. So at this point, you get this nicely, and underneath they're all zeros, right? So this goes to the right, this goes to the right. So you will write this as row echelon matrix. But this is not row reduce because this one is still not 0. For reduce, when you see 1, everything else has to be 0. But you can do this 2 more times. Okay. The next one is to make this 2. So you will use this to make this 0. So you multiply. What is this number? 2. The negative is negative 2. So negative 2, row 2 plus row 1. Okay, this will be okay because this is already 0. All right. So you will do negative 2, row 2 plus row 1. Only for this. Don't do this yet because you will change it. You have to do it another time. So do this first, then you will get, okay, the one that is changed is row 1. So just copy row 2 and row 3, right? And make sure you copy it correctly. Some students make a silly mistake or careless mistake. When you copy wrongly, you get the answer wrong. Okay. Copy. Okay, -2 and add. This won't change because this is already 0. -2 and add. 6 and add, which is 9. Okay, so one last one is by making this and this 0. All right, so what you will do is, what is the number here? 9, so -9 row 3 plus row 1, and you can do this together. Number is -3, so you take 3 row 3 plus row 2. And the one that is changed will be row 1 and row 2. So this will give you, okay, so I copy this, right? Of course I will get 0, that is why. I get the identity matrix actually, right? But not all the time. Doesn't have to be identity matrix. It can be others, like the one that I show number 5 just now. Okay, and this is REM. Because there's a 1 and then the rest are all zeros. It doesn't have to be identity matrix. Yeah, doesn't have to be all zeros. The others. It can be, I will give you one that doesn't have all zeros. Okay. Okay, one other reminder. When you do row operation, you have to do this way, one row, and then continue the second row like this. And then the third row, I didn't have place here, so I just put here. But do like this. Because I found some students last time do this. Okay, or this, go to another. So do it. Easy for me to check. Because I didn't just look at the answers. I look at your operation. Otherwise, I'll just give you 0 for the wrong answer, right? But I want to see whether you understand where actually you did the mistake if you don't get the right answer. Okay, so boleh screenshot je kan, copy later. But I open to question. Anybody has any question? Raise your hand and ask. Which part? We will do more in the next class.